Okay, the second video for worksheet 18. We have made it all the way to problem 13 and 14. Draw a Thevenin circuit. If V Thevenin is 3.8 and R Thevenin is 34, convert it to a Norton circuit, and then 14 is draw a Norton circuit, convert it to a Thevenin circuit. So if I go to the source, you can read about Thevenin and Norton here, and a Thevenin circuit and a Norton circuit have a very definite appearance. Okay, so my Thevenin circuit is a voltage source in series with a resistor going out into a larger circuit attached to A and B here. My Norton circuit looks like a current source in series, or in parallel, excuse me, with a resistor going out into a larger circuit. Okay, so when I ask for a Thevenin circuit with a Thevenin voltage, I'm asking for a circuit with a voltage Thevenin equal to whatever value I give you, and a resistor Thevenin with whatever value I give you. I'm looking for a circuit in this form. If I ask for a Norton circuit, I'm looking for a circuit in this form. It'll be a current source and a resistor. Okay, so that's pretty straightforward in terms of, whoops, went to the wrong page. There we go. That's pretty straightforward because I give you the voltage and I give you the resistance. Okay, so I want you to draw it as a Thevenin, and then I want you to convert it to a Norton. In the Norton, I want you to convert it to a Thevenin. So if I go to the web part and I do Thevenin-Norton equivalencies, what you see in the text is he's got a Thevenin circuit, and he's got this little box around it. And this little box can be interchanged with this little box down here. So it doesn't, you don't really know what you've got inside. If you couldn't see it, if this was covered somehow, you could either have a Thevenin circuit supplying this load or a Norton circuit supplying the load, and it would have the same characteristics. Okay, so that's the whole point between Thevenin and Norton, and being able to convert between. Now, how do I convert between? Well, he does it for you. Your Thevenin resistance and your Norton resistance are the same. And then your voltage Thevenin is equal to your current Norton times your resistance Norton. So I times R is E. And if I scroll down, your Norton current is your V Thevenin divided by your R Thevenin. So the conversions are pretty easy. Okay, let's see. Now go back to the right one. So you should be able to do that. Looking for two circuits. One is a Thevenin, then it's Norton equivalent, a Norton circuit with these dynamics, and a Thevenin circuit. For 15 to 18, consider the circuit and then put in your nodes. Now, open means it's been removed. Shorted means there is a small resistor in parallel with it. Okay. And then finally, find the fault in the instructor-built circuit. So here's a circuit. It's the instructor-built circuit. And if I go back to the right tab, that's what it should look like. If you drew it out, you could flip the 7.5K up if you want to. So node 1, node 2, node 3, and node 4. So find the fault. Okay, so what I'm going to do is I'm going to go in here and I'm going to edit the document and tell you that for the faulted circuit, V1 equals 7.5 volts, V2 equals 6.57, V3 equals 3.76 volts, and V4 equals 3 volts. So those are the values that you would measure if I had built the circuit and you came in and you measured from V1 to 0, V2 to 0, V3 to 0, and V4 to 0. And I'll clean that up a little bit. There, how's that? Anyway, hope that helps, and that should help you complete worksheet 18. Thanks for watching.